In this video, I will discuss the lease or rent decision, and we'll basically look at which one is better. Before I start and I go forward, I want to highlight again that for some reason this firm has decided that it will get the asset. The asset is worth $5,000. Maybe we are only replacing an old asset. Maybe in that case we just write, we know we need the asset, we've been producing and productive with that asset, so we don't really need to do an analysis to identify if we need to get the asset or not. Or it's possible that we already did an NPV analysis and established that we do indeed need this asset and it will generate positive NPV for the firm. But the important thing here is that we can ignore all the positive cash flows that this asset will generate. We're just trying to decide, should we lease the asset or should we rent it? So we're only actually interested in the cash outflow. And we know the NPV in this case will be negative, right? But we want to take the NPV that is the lowest negative. So just something important, you'll see I don't consider any positive cash flows, right? But again, it doesn't matter. We know for some previous analysis or something that we need that asset. Or because it's just mandatory, we need to have it. So then we just find the cheapest way to do this. Okay. Before going further, though, I want to say, so this asset is worth $5,000. We can borrow it for $5,000 over 5 years at an interest rate of 10%. This gives us 5 yearly payment of $1,319. That's actually not exactly true. If you take your financial calculator, you'll find that the payments are actually $1,318.99. Okay, so I'm rounding here. The textbook is rounding, and what that will do is if you use all the decimals, you'll see small little mistake that will crop up. The values will be different a tiny bit. Okay, I'm going to use a rounded value just because it's a little bit easier, but we could actually do it with a non-rounded value, and we would get the exact answer. So just something to keep up. The other thing we could do is we could we could lease the asset for 5 years, and in that case we would have lease payment of $1,295. Okay, I have the tax rate here, I have the CCA rate here. Okay, and then we just need to decide. Before going further with this decision, I printed an amortization schedule here, and it's really important because when we will need to look at two different situation here, right? We'll need to look at the borrow to buy decision, and we will need to look at the lease decision. Okay, what are the cash flow in the borrow to buy? Well, the cash flow in the borrow to buy will be the loan payments, right? We will make loan payments every year. And so that's a cash outflow, okay? And at the same time, though, when we pay interest, that is going to be generating a tax shield. So we're going to get a tax shield from the loan. And finally, the last payments is we're going to get a tax shield from the asset. We bought an asset worth $5,000. So we will have a CCA that we can use as amortization, right? That will reduce our expense. In the case of the lease, what are the cash flows we're going to get? Well, we have the lease payment. But the lease payments and these payments are usually at the beginning of the year. So I'll just write BGN, right? Because they're at the beginning of the year. But these lease payments will generate something, right? These lease payments will show up in our income statement, and they'll show up at the end of the year where they were paid. So they will give us a tax shield. So we're going to get a tax shield from the lease payment. Obviously, all of the tax shields are basically cash inflows. All of the payments, the loan or the lease payments, are cash outflows. Okay. Now, the thing that's complicated is these two things here, right? It turns out that they're actually really simple. But as usual, I just want to do one quick example. You don't need to ever do this yourself again. Okay, you'll know always what the answer is. But I wanted to do a quick example in this case to showcase what I'm talking about. Okay, so For example, here, I borrow $5,000, right? And I will repay this loan with 5 payments of 1,319. Okay, so I have the loan amortization schedule here. That's what I have in this part. You should be able to do this. The BA2 Plus can do this, right? If you put all the information here in your time value of money buttons and you go in the amort table, second function amortization, you can actually make this whole table. I made it on Excel in this case, but you can easily make it with your BA2 Plus if you want. Okay, and this is just the loan amortization schedule. I borrowed $5,000 at year 0. At the end of the period, I make my first payment. I need to pay 10% of this value as interest, so I pay $500 in interest. And then this number minus this number is by how much my loan will go down, right? By how much the balance of my loan will go down. So the balance goes down by the difference between these two numbers, and the balance of my loan goes down to 4,181. And then next year I'll have less interest, and so on and so forth, and you can keep going until the loan comes down to 0. Okay, those are my yearly payments. And we could find the PV of that pretty easily, right? The interest rate is 6%, and we can just find the PV of this. But the difficulty comes from the fact that this interest that I pay generates a tax shield, okay? And in this case, the tax rate is 40%. So if I need to pay $500 in interest, well, I get 40% of $500 as a tax shield, so that $500 of interest payment will generate $200 of cash inflow for me in that year, okay? And that 418 will be 167. Again, it's just 40% of that number will be that number here, right? Okay, now I can calculate the after-tax cost of my debt, right? I borrow $5,000 and I need to pay 1,319. But I get a tax shield of 200. So 1,319 minus 200 gives me my after-tax cost of my loan. In the second year, I make the same payment. I have less in interest that is paid because the balance is lower, so my tax shield will be a bit smaller. And this is the after-tax cost of my debt. This number minus this number gives me this number here. Okay, and you can do that for all the other rows if you want. I won't do all of them, but I have all of them if you want to try to do them. Okay, so this is the actual cost that I should use, right? When we calculate what's the cost, what's my loan payments, so what's the value of my loan payments plus the tax shield from the loan, I can just calculate the PV of these payments here. Okay, I calculated the PV. Calculating the PV should not be difficult for you, right? I told you that in this case, the interest rate that we use, the discount rate that we use is the after-tax cost of debt. So it should be, the discount rate that we should use should be the yield on my bonds times 1 minus T, the tax rate, which is going to be 10%, the cost of my debt, times 1 minus the tax rate, 40%. So the discount rate that I should use in this case is 6%. So I calculate the PV of these payments here, the after-tax payments, right? I put that as my FV. I calculate the PV using a discount rate of 6% and these years as my number of periods. And I can find the PV of the tax shield, which is what I did here. If I sum up all of these payments here, I get exactly the value of the loan. Okay, so this was a pretty long introduction, a pretty long way of talking about this. I wanted you to just see it once. I don't expect you to ever redo this for me in any exam ever. Basically, I just wanted to convince you that if the discount rate is the after-tax cost of debt, then in that case, the sum of the loan payments as a negative number plus the tax shield from the loan will always be equal to a cash outflow that is exactly equal to the value of the loan, the $5,000. So you actually never need to do that, but it's really important. It's because we use the after-tax cost of debt here and not just the 10% as our discount rate. If we use 10%, the sum of these two would not give us the $5,000, right? It's because we use 6% here. So just really important. You'll usually have to calculate these two, but it's pretty straightforward. It's just the value of the loan. Okay, so you don't need to have a big headache here. You don't need to calculate the PV of anything, right? You don't need to calculate the PV of these and then the PV of these. You don't need to do all that. It's just always going to be the value of your loan. Okay, so now that we dealt with this, let's go with the rest. Okay, so we're going to pay $5,000 if we borrow to buy. We're going to pay $5,000 for the asset today. Basically, that's the present value of all the payments we're going to have to make. Then we need to calculate the tax shield from the asset, and the tax shield from the asset should be pretty straightforward. We can just use the PV of the tax shield formula. Okay, so the PV of the tax shield should just be an equation that you know really well at this point. The PV of the tax shield is just as follow. It's the value of the asset by how much my asset pool will go up, multiplied by the depreciation rate 40%. Whoops, 40. Sorry, the depreciation rate is 20%. Doesn't really matter because it's a multiplication here. I could have changed the order and it wouldn't change anything, but just to not confuse anyone. Then I multiply by the tax rate. I divide by the depreciation rate plus the discount rate. And in this case, remember, the discount rate for everything except a potential salvage value is going to be 6%. So we're just going to use 6%. And then again, do not forget to use the half rate rule. So we're going to use 1.03 over 1.06. Okay, so we can just put all of that in our calculator and we get the answer. I'm just doing the first parenthesis here, this part. Okay, so it's 0.2 times 0.4 divided by 0.26. I'm going to store that as 1. And then I'm going to do 1.03 divided by 1.06. And then I'm going to store that as 2. Okay, and I have 5,000 times what we saved under 1 times what we saved under 2, and that we have the PV of the tax shield is just 1,494.92. Okay, this means that the NPV of borrow to buy is just going to be 1,494.92 positive today from the tax shield, and then we're going to need to pay the PV of our loan payments, and then we're going to get the PV of the tax shield from the loan payments, but we just established that this is always going to be $5,000. And the NPV of the borrow to buy decision will then be this number minus 5,000. It will be minus 3,505.08. Okay, now again, this video will seem really long, really overwhelming, but it should actually be pretty straightforward. I just wanted to establish and to demonstrate once and for all that the loan payments plus the tax shield from the loan will always just be equal to the value of the loan if the discount rate we use is the after-tax cost of debt. Okay, so that should be clear and that should be pretty straightforward now. And then the only other thing you have to do is calculate a PV of a tax shield, which you should be able to do at this point in the class. And if that's the case, then it's pretty straightforward to calculate the NPV of the borrow to buy decision. I will stop the video here because I think it was pretty long. In the next video, I'll just discuss the lease decision and what's the NPV of the lease decision. Yeah, that's it.